Hello, good morning, sir.
Good morning.
Sir, can we start the introduction?
Yes, definitely. You now proceed.
Okay,
Without,
okay.
you
Miss
can.
Munira, Miss Munira. Miss Munira, you may start.
Okay, sir. Good morning, one and all. I heartily welcome all the participants, volunteers, and our respected speaker in the 1 week advanced FDP on fundamentals of geotechnical and structural engineering for sustainable infrastructure development. Today, we welcome our respected speaker, Dr. C.D. Modhera, sir, to deliver his expert talk on recent advances in concrete technology. Sir has teaching experience of more than 30 years and he is also the chairman of ICI Surat since 2017. Sir has published more than 125 papers in various national and international conferences and journals. Sir has delivered more than 50 expert lectures in various STTPs, FDPs, seminars and workshops. Sir has guided almost 19 PhD students and 8 are ongoing. Sir has a very good expertise in concrete technology and today we have to take the advantage of their knowledge. Once again, I welcome sir and I request sir to start the session. Thank you, sir.
Thank you, Sunita. Yeah, and thanks to organizer. First of all, I congratulate first of all because of your timely, organizing and benefit to the various participants. Such kind of activity. It is very nice to hear you, and I'm happy to say again, I'm here because of you people invited. I thank to principal Dr. Brahmbhatt and Dr. A.P. Parikh and others, his team. They are very much, you can say, compliment for the same team, and thank you. Now, basically, this concrete technology title itself, you are asking that fundamental is very, you can say, once any research will be done, that is based on fundamental only. So unless and until you are not, you can say, clear about the fundamental, then definitely it remain in, you can say, paper. So fundamental is, so you must visualize. Fundamental is clear, then you can visualize and you can think for the further research. Any, maybe analytical, numerical, and then this is experimental. Any material side, design side, or analysis, or combination of both, right? So this is what actually very good topic, or you can say topic of FTP is chosen by organizer. Now I am sharing my PPT. So let me, yeah, people are waiting. Let me minimize it. Yeah. So in continuation same, I have chosen just very basic and core topic, that is concrete technology, recent advances in concrete technology. As you aware that concrete is again very much we are using so far as India is concerned, or abroad also, because of now abroad they are moving forward, for the height point of view. So then they are using composite kind of structures, or with the help of steel they are going ahead. So far as concrete is basic material, so we should aware what is the, you can say, recent advances in taken place. That is just everybody are knowing. This subject is vast. Let me first clear, because of it may go in this corner, that corner, but prior to that, let me put my outline of the presentation, first we should aware that whenever you can say you are writing thesis or you are presenting seminar, then kind of first chapter always come, introduction, and then further subsequent. Similarly here also, so far as concrete is concerned, history of concrete is again need to be understand. Then mixed design, what is it? Then again it can relate with human body, its nature or behavioral part is concerned. Then there is fourth one, which is earlier it was not there, but now so many, you can say, concretes has been considered, which is different than traditional concrete. That's why adjective has added special concrete, so which deal with the different behavior than traditional or conventional concrete. And then one of the very good topic, when delay criteria happen due to any accident, due to accident arises during casting, then what is the delay behavior, or that is called partially set reinforced behavior or partially set concrete behavior, we can discuss. It is again very good topic and very scope for further research. Kindly bear with me. Then case study on selfing concept, that also I am trying to explain. As I told, that concrete is the second most consumed substance on earth after the water. That is everybody are knowing, still it is repeated. So that's why we should aware that how its consumption is arises or consumed substance is there. The relation between, you can say, doctor and medicine is same as to the relation between the civil engineer and concrete. So that is what we can say, visualize how importance of the civil engineer and how it is related to concrete. The making of concrete is an art as well as science. So basically this is very preliminary. Now historical development, so far as basically invented, you can say, even you can look at that Egyptian pyramid, that is 3000 BC, you can say. So that is, you can look at, they mixed mud and straw to form bricks that time and used gypsum and lime to make mortar. Then comes 300 BC, and you can say Roman architecture. The ancient Roman used a material that is remarkably close to modern cement to build many of their architectural marvels, such as the Colosseum and Pantheon. And the Romans also used animal product, their cement, as an early form of admixture. So remember, they knowingly or unknowingly, even animal product put in concrete or mixture, and then later on it was found that they are acting admixture. Basically, from this onward, we are now knowing what is OPC. So in 1824, Portland cement invented. Joseph Aspdin of England is created with the invention of the modern Portland cement. He named his cement Portland, and after rock quarry that produced very strong stone. So it is called his tenure was 1778 to 1855. So in between he made in 1824 this invention of the cement. Now what is content of cement and how it came, what is the process, that is again I hope understood well. Still if it comes, then I will again discuss of the same. Then from 1824 then onward, it was again put proper, it's some test, you can say, that powder he made. So first test of the tensile and compressive strength took place in Germany actually. So tensile means with the help of only cylinder, split tensile. Soundness you are knowing, Leach-Atelier method now we are knowing. Finesse also we are knowing. It can be done twice way. Two means one is dry powder sieve analysis, 19 micron support to be used, and then second is plain air permeability test for finding its surface area, that is centimeter square per gram, otherwise meter square per kg, how much area is covered by that respective particle of the cement. And setting time also important, because of that is again it should not set early, it should not set even taking longer time. So that's why it is categorized two way, initial setting time and final setting time. So that is we will not discuss, but procedure, everything you are knowing or supposed to be known. 1889, then again Alwar Lake Bridge also, you can say concrete reinforced bridge was built in San Francisco. Bridge is still exists today. It means that it is done in those days and still it is existing. Of course, time to time periodical maintenance is very much required, which you can say our Golden Bridge also, of course it is still, but it is still maintained properly, then you can say it is existing. However, its lifespan is, or the design life is over, still it is working well. 1891 concrete street. The first American concrete street was built in Bellefontaine, Ohio. So I think this is just sake of information. Even Inglas building also there. It was built in 1903, and first concrete high rise was built up. High rise means you can look at least 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, something. More than 50, around 15 story. This building has 16 story, and was great engineer feat of its time. So I think this is what I wanted to say. Whatever is development taken place, everything came from abroad only. You can look at. So I mean, we have to think now. Even for that also, we should we should take or do the study or literature study from that, and then further we can incorporate in Indian context. That is very much needed. 1908 concrete home, that is Thomas Edison designed and built the first concrete home in Union, that is New Jersey. So I think this is one of the building I wanted to show that it was also made from concrete. Ready mix, I think that is just not related to structure, but you can say first load of ready mix was delivered in Baltimore and Maryland. So 1915, even color concrete was, you can say, invented, and then behind that, Lean Mason, Scofield found that first company of produce color cement or color concrete. Basically, it came with only pigment that everybody are knowing, but still we can discuss later on if it is. Then in 1930, air entraining agent also introduced. And then it resists against the damage from freezing and thawing kind of things. So that I think this is just in sequence I wanted to show that what are the, you can say, development or advances taken place, little start from its beginning to till date. 1936 Hoover Dam, that is also there. In fact, Indian is just missing that our recently we have, you can say having Statue of Unity. That is of course need to be included, but not I am finding. In 1938 concrete overlay. John Crossfield added latex to Portland cement, aggregate, and other material. Now other word introduced in 1938 to make covering for ship decks. 1950s decorative concrete develops. That is also, you can say that Brad Bowman developed the Bowmanite process. So I mean everybody have put thought and application in those days. 1967 concrete sports dome. The first concrete dome sports arena known as the Assembly Hall was built at University of Illinois. Then fiber reinforced. People are talking fiber reinforced concrete, fiber reinforced concrete. Only thing is that what is the function of the fiber? Everybody must be sure to why we are using fiber. It will never increase the compressive strength, but it will increase the tensile strength of the given concrete. So basically fiber, even our RCC also consider where we are putting bar in tensile zone. So that RCC bar or that concrete also, that RCC bar called as a continuous fiber. Continuous fiber. So fiber role is to increase or enhance the split, not tensile strength of the given or existing structure or particular beam. If we are inserting, then you can say beam. Now later on in 1970, because of it is possible to, because it is a straight bar, sometimes you can bend also, but whenever beam column junction arises, that time the amount of the total area of the steel will definitely more than as usual. So that's why space for the concrete sometimes not very much available, and that time even 20 chips or coarse aggregate if you have used, so sometime 20 space may not be there. So there is a chance to remain voids, particular beam column junction. And then when voids is there, definitely it will become weaker later on. In transition zone you are knowing. So for it become weak, actually cement paste will be minimum. So in that case, we are supposed to use the discrete fiber made by steel, maybe glass or any material prevailing, and then that discrete steel fiber if you have used, then it can be work as good as continuous fiber only for certain depth and width, and that is derived based on aspect ratio lambda, that is development L by K or L by D ratio. The aspect ratio is L by D. Suppose if it is circular in nature. So I think fiber reinforced concrete nowadays, so many, even acrylic fiber also there, GFRP also there, so many, I mean discrete steel fiber also there. GFRP is different, that is in sheet form, that also we'll discuss. This is another structure. Now concrete engraving, that is also one of the system, you can say, how we can get the different shapes. Tallest concrete building. The tallest reinforced concrete building was built in Chicago, Illinois. The 65-story building is known as only by its street address. So I think this is again tallest concrete building, was developed or built up at 1992. 1999 polish concrete also introduced, you can say installation of polish concrete in the US only. Area was 40,000 square foot warehouse floor for the Bellagio in Las Vegas. These are the various pictures, you can just visualize and see. The first is caves where last used is habitant around 8,000 BC. Remember, African hut at Bana, a small village of the Cameroon. Then Kukulkan's pyramid. So it is pyramid, Egypt. The Roman bridge also shown. Then first arch bridge in world to be made out of cast iron. Remember, it is a steel bridge, you can say, material which was previously far too expensive to use for large structure. Now we usually not preferring this kind of bridge. It is very adding high cost. Then the Burj Khalifa, United Arab Emirates, in the tallest man-made structure ever built. It is supported by the reinforced concrete core basically and using special concrete mix. So I think this is just glimpse actually. It is not sufficient for I already declared very beginning something can have about the idea how what is the you can say advances taken place. However, we are talking or we are from India, so we should know the Indian standard code. Basically, for any mixed design of the concrete, you can say concrete mix proportioning guideline was prepared in the IS banner or IS name 10262. It was 2009. Of course, 1982 was first, which is not written here. And then 10262, now 2019, just minor, of course, title is minor changing, that is guidelines for concrete mix proportioning. Meaning is same. But it includes many things. So what is first aspect? Air content. In 2009, element consider of air content in the mix proportion calculation as it's not of much significance, while in 2019 consider expected air content 0.8% to 1.5% in the design process depending on the nominal maximum size of the aggregate. So I think this is added. Similarly, that is very important, water cement ratio. Any talk is there, usually I am giving example. What is water cement ratio? It is in layman language when you are preparing at home by your sister or our mother, then they are always keeping some, you know, proportion to get good taste of the halwa. Same thing in concrete mix also, water cement ratio should be optimized in such a way that it should give the workability as well as strength. Now come to the technical. Strength means after hardening, after introducing the CSH gel phenomena, sufficient water should be available, and then again mobility of the all particles should be introduced. That is workability, and that workability should be there. If you are adding more water, that is also will give good mobility, but same time it remain voids also, and you can say final it result reduction in strength will be taken place. So I think water cement ratio is again important parameter. However, in 2009 table 5 of IS 456 for desired exposure condition, remember exposure condition is play key role so far as concrete mix design is concerned, and that is very important. Preliminary water cement ratio that has to be further checked for limiting value of ensuring durability. So these are the statement is available in 2009. 2019 selection of the preliminary free water cement ratio may be adopted from established relationship. So one graph is given, and from that different graph you can get expected, or you can say some strength ratio, or sorry, water cement ratio, and further check need to be required. Mineral additives is added, and however in 2009 also given additives fly ash, silica fume, GGBS, rice husk S can be used like that. It was given a durability requirement met with, but there were not clear cut thing was available, but now additives is now given in weightage. 20% and more fly ash, 30% and more GGBS can be used. That is directly given procedure point of view. Double. You can tell that come at 1 o'clock. So, sir, 1 वागे. Various requirements have been modified. Okay, so I mean these are the options we bolded are. This is new IS code. I can say latest IS code is 2019. Now miscellaneous many things explained, but here I have given 2 point only. Various requirements have been modified in line with the requirement of IS 456. This is our great, kind of Bible or Gita, IS 456. So far as RCC is concerned, we should aware of the all update. Now we are say 456 2000 we are using. An example illustrating mixed proportioning with supplementary symmetry additives was used fly ash only. In 2019, various requirements have been modified in line with the requirement of 456 for the water reducing admixture. An example illustrating mixed proportioning with supplementary symmetry additives, fly ash, even high strength concrete, mass concreting and self-compacted concrete has been included. So look at, they have added the special concrete section. So I think if you have those things, you can read from their IS code, and specifically special concrete they have made the procedure how to build up. So we are talking about concrete. I think that we have very much scope to discuss about this topic, but still I have given few basic things how it is different and what is included. So 2019 is better than you can say previous all IS code 1982 and 2009. We are talking concrete human body. Suppose what is how it relates. Human body means it is a living thing, and concrete usually we are calling non-living thing. But behavioral part, if you are relate, then both have the same kind of taste. Then it is sometimes basically as a civil engineer or concrete technology, you can say concrete also living thing. How? Only difference is there. Human being is concerned, it need ingredient to survive: protein, carbohydrate, vitamins, mineral, and fat. In concrete, basically, ingredient is involved water, cement, coarse aggregate, even fine aggregate, sand, you can say, and admixtures if required. Essential requirement, basically, human also need air and water, and here essential concrete make very good, then mixing, compaction, and curing is required. Standard for good life. We both have must good life. Then what is involved in human? Roti, kapda, and building. You can say makan. And concrete mainly strength, quality, and durability. So these are three fundamental different between each other. Major factor affecting health, that is blood pressure mainly. If low, high, then it reflect on human health. Similarly, in concrete, water cement ratio. Now weak in tension, both are in tension. Both are weak, you can say in tension only. So tension is not appreciable. And as we know, as a structural engineer, anything is there, then tensile stress we give, importance to design tension only. So that's why in a way we are not happy with, we are not appreciate the tension, right? So tension is again avoided. To increase the tension, stress or resistance, we added the fibers continuous fiber means that is RC bar in beam, and at beam column junction we added the fiber, discrete fiber, to remain in intact. That is also work of the increase the strength, tensile strength. Skeleton made, here bone is involved and here reinforcement is involved. During early age, what happened? Human being remain wet and dry, as you know, dry and need hug. Here also remain wet and dry, but needs curing. During middle age, so far as human is concerned, it needs exercise. Exercise is required, and sometimes needs medicine also. Concrete also needs maintenance and needs repairs. That is during middle age. It is just more than its early age. This first is early age, then middle age, later age also major operation, strong medicine, organ transplant, etc. Concrete also needs major strengthening. Now, that last one is again very interesting, that human also need to diagnosis its behavior or its health. Then so many tests has been derived. Everybody are knowing CT scan, ECG, you can say, echocardiography, biopsy, etc., etc. But here also, concrete also we should measure its strain measurement, pulse echo method, UPV sometimes we are calling, and so many. Or sometimes biopsy kind of thing, that is called core, concrete core cutting, petrography and chemical examination. Rebound hammer test also we are usually using. So I think few tests is very popular, you can say, that what we are using. So I think this is the meaning, how you should not take so easy, but concrete also as good as human only. That is my intention to convey. So if you have, suppose all of a sudden weight on your head, you will get, you can say, compressed. Same thing, if our concrete is made in some of the material and it designed for M30, and all of a sudden some impact load is introduced, definitely it will get crack, or you can say if it is beyond its capacity. That is the intention. So certain knowledge of mechanics of solid is very much required. Right? This is the thing what I wanted to say. Special concrete overview. So there are few written over here. One is geopolymer concrete. If I go horizontal, then self-compacted concrete, pervious concrete, high volume fly ash, then silica fume concrete, photocatalytic concrete, then high performance concrete, ultra high performance concrete. This is the same more or less, but ultra high means it relate with the very high strength concrete, lightweight concrete, and autoclaved cellular form. So these are the few are noted, mainly popular, you can say. Every concrete have own principle to make the mix, right? Special concrete in recent trend is concerned. Why it came into picture? Why not traditional still going on? So several drawbacks, you can say, such as low tensile strength, permeability to liquids, and consequent corrosion of the reinforcement. That is also one of the issues. And susceptibility to chemical attack and low durability. So I think these 3-4 parameter is very much involved to think for develop new concretes which cater, you can say, fill the gap. That's why. So modification have been made from time to time to overcome the deficiency of cement concrete, yet retaining the other desired characteristics. Recent development in the material and construction technology have little to significant changes, resulting in improved performance, wider and more economical use. Right. So this is the just some point is written over here. Just next. This is again picture. Just visualize what is autoclave aerated concrete. Now, this AAC block you could have seen it is lightweight. So that is just everybody are knowing. But what is it basically? AAC block is very lightweight. Basically, those who are we are designing RCC building. If we have taken solid, I mean, this is to be used for the case of the infill. If infill itself having much density, then the weight will be increased. So that weight also we need to fill it. I mean, that weight should be considered while design. So if we reduce, then dead weight maybe can consider little than previous. Another expansion agent that cause the phase mix to rise like bread up. In fact, this type of concrete contain 80% air. That is one thing. In the factory where it is made, the material is molded and cut into precisely dimensional unit. So this is related to AAC block. Cured block or panel of autoclaved aerated concrete are joined with the thin bed mortar. Right, mortar is again to be used for joining that joints, filling that joints. Component can be used for the wall nowadays, even floor and roof. So these are the wall comes means it is infill. Roof also now presently using. So you can also visualize later on that I will show that one picture. Here what are the material is required basically? Portland cement, lime is required, and then polarized fuel is PFN. Or fly ash means processed fly ash. Portland cement, lime, then fine silica sand also required. Small amount of the anhydrite or gypsum is also often used or added. Autoclaved aerated concrete does not contain any aggregate. All the main mix components are reactive. The sand inert when used in dense concrete behave as pozzolana in the autoclave due to the high temperature and pressure. So here one parameter you can show high temperature and pressure is required to build to manufacture such kind of block. What the advantage to use this kind of block? I already told. Mainly it use basically lightweight is there. So design and construction flexibility and ability to make easy adjustment in the field. Autoclaved aerated concrete combine insulation and structural capability in one material for all if it is made single panel, roof, floor, etc. One good thing is that dimension stability. It will be perfectly throughout dimension remain constant. So that's why it is dimensional stability is there. Durability by default. Double AC resist water basically. Rot, you can say mildew and insect. This is one thing. Another units are precisely shaped. That what I was telling. Conform to tight core tolerance. Fire resistance is excellent with 8-inch thick double AC. It is not as widely available as most concrete product. That is one thing. This is disadvantage. Because it is lower strength. This is another issue than most concrete product. It also requires protective finish since the material is porous and deteriorate is left exposed. So I think this is just way it is written disadvantage, but over that advantage is much in application so far as this double AC block can be used building stone prefabricated component, you can say stair, firewall, roof, ceiling elements. Another concrete that is where air entrained concrete, you can say. Air entrained concrete is produced by using either an air entraining agent or cement, or adding any air entrained admixture during batching. Material also we will not discuss much, but still you can say air entraining admixture consists one or more of the following material, that is wood resin, that is winsol resin, or sulfonated hydrocarbons, sometimes fatty or fat, and resinous acid and synthetic material are to be used. And this concrete is again similar to previous, but little here we do, because of presence of the air entrainment concrete or agent, it reduces the segregation and bleeding. In concrete, these two phenomena is attached. Segregation and bleeding is not appreciable. If it is good to resist segregation and bleeding, then this kind of concrete is good. Permeability also sound. You can say very much it is impermeable, and formation of latents also you can say resist or reduces. Air entrained concrete is frost resistance. And application as usual must be used in structure that will be exposed to the moderate water saturation. So I think again I am reading, air entrained concrete must be used in structures, means RCC structure, which will be exposed to moderate water saturation. Okay. Disadvantage is again we have to use air entrained, so cost will be added. It lowers the density, it is lightweight, so then it liable to shrink also later on. Drying shrinkage is there, and for every 1% increase in air, the compressive strength also will reduce by 2 to 6%. So I think one way we are getting advantage, and other way we are also compromised with some disadvantage. So where and why we are using it must be clear, and looking to the quantum of the project or importance of the project, we have to select the appropriate material, right? So uh, just so fiber reinforced concrete is, I told, is contain dispersed randomly oriented fiber. Earlier I talked, I have given something about the importance of the fiber. Fiber have been produced from steel, plastic, glass and natural material in various shapes and size. Aspect ratio typical range from 30 to 150. So this is the aspect ratio. Aspects that I told, lambda is minimum 30, maximum 150. So that is ACI, American Concrete Institute, that SP 75 is there actually. So that from that they have given some guideline from research only. Fiber 1, 2, 3 means maybe acrylic, maybe glass, maybe carbon, maybe steel. What is its specific density or gravity? What is given? Specific weight, I must say. What is lambda suggested? What is the range of the diameter is available from which to which? Everything is very good way done. How to calculate the percentage to weight to volume to weight, volume to weight, or weight to volume, like that. Very good. One DJ Hanan textbook is available. You can refer. It will give the good knowledge about the fiber reinforced concrete design. I told that material, when FRC is written in a discrete manner, so one is steel fiber, then micro synthetic fiber, macro synthetics. Micro and macro you should know. So of course range is given here. Micro level means very less diameter. So far as unit is concerned, macro means it may be in mm. Glass fiber, cellulose fiber, natural fiber, PVA, polyvinyl, fiber, specialty fiber, steel and micro and macro blends also available, and other fibers and blends. So I think it's written in such a way that where which one we have to use, mainly because of this fiber reinforce. So fiber generally increase the first correct, that is flexural strength, direct tensile strength, and split tensile strength. Compressive strength little may exhibit a minor increase. This advantage you read it. So uh, here, because of presence of fiber, what are the chances? One is balling of fiber in mixture, which is hinders become uniform distribution and reduce the workability, right? So I think fiber one way it is okay, but same time we should sure about the its proportion. It must be properly mixed, and homogeneity must be induced or produced. That is very much required. Okay, so today is first, second. Today is first date.
First. Second.
So you can deposit. So polymer discuss in detail. Then geopolymer is concerned with just it is visualized what are the main ingredient need to be considered. In fact, here cement is absent. Some kind of fly ash or GGBS we are using. Then aggregates.
You know, Mali Javed.
Water is there, activator is there, and you can also include this water at certain small amount whenever it is
The
required.
register magnet.
Now,
हाँ,
geopolymer is concerned
तो तुमने चाय खाओ पर से कैसे खुद ही कर.
are inorganic polymer composite which are prospective concrete nowadays with the potential to form substantial element of an environment friendly or environmentally sustainability construction by replacing or supplementing the conventional concretes. GPCC have high strength with good resistance to chloride penetration and acid attack. People are shouting that we are not using cement at all, so it will, you can say, reduce these CO2 emission in environment. That is true, but not 100% because of some amount of the preparation of this element also some inhibit the CO2. So that's why, but ultimately it reduces the emission of the CO2. And one more thing, chloride is not there. So it is, I mean, having chloride in that material, but with respect to our cement and other, then chloride penetration will be minimum or it resists, you can say. That kind of property is existing in geopolymer. These are commonly formed by mainly, alkali activation of the industrial aluminosilicate waste material. Generally, we are using that is fly ash, GGBS, and have a very small greenhouse footprint when compared to traditional concrete. So I think this a very long back. If I talk that fly ash was not using and it was just considered a waste, and heap of the fly ash is too much nearby Kankarapar and any plant, you can say, which is producing the power. So coal base, you can say, and then they are, you can say, producing huge amount of the fly ash. So it is to be used properly. So now people have put thought in those days. Even I remember 10 to 20 year back that government of Gujarat has imposed in one of the circular that compulsory you have to use the fly ash in your concrete. So the idea was that utilize that waste. Of course, now later on it was processed, it was added and found its, by now instead of waste we are calling byproduct. Similarly, GGBS also one of the industrial waste, and we have put thought to utilize in our concrete. So I think this is the, and then by way, whatever the percentage of the fly ash and GGBS we are using, it is reduces the use of the cement. That is also one thing. Material is required. You can say FA and CA is required. That is fine aggregate, coarse aggregate, and you can say catalytic liquid system will be introduced. It is stronger, basically, more resistant to chemical and corrosion, and has more possible application. Geopolymer. Concrete is not wonder material. Remember, it is already there. It need to be speciality tailored to be able to handle itself in certain situation. In fact, it's not much popular because of only thing is that it need thermal curing kind of 60 to 80 degree. So in situ concrete it sometimes difficult to give those kind of temperature, but in a precast kind of thing which is factory shade, those in factory it can be done in huge manner. That is sleeper is there, any pole is there, kind of beam, whatever you calling, that can be done in the, it is possible to give the even those temperature in that factory. But in situ is people are doing, the people are now changing those material at certain extent, adding some others, so itself it cured, you can say, no need to give external temperature, or you can say it should cure with its ambient air temperature. People are working. Then if we succeed, then I think there is a chance to come. But here, skill person is very much required to produce it. More reliable, extreme environment also when compared to ordinary concrete. Disadvantage I told earlier also, skill person is required. So special handling need difficult relate to the creation of the geopolymer concrete. Geopolymer concrete requires the use of chemical basically, which is sometimes harmful and not to handle properly. If it not handled properly, then it will give the negative effect. Sodium hydroxide can be very harmful to the health if mishandled. Since it is a strong base with pH 14, so sodium hydroxide is also very corrosive to area such as the eyes as well as skin and nose. So I think these are the attach the disadvantage also. But still I can say, if people have worked for that and those things, it was checked for durability also, and it is found good behavioral part if geopolymer or GPCC is concerned. One possible application geopolymer is the construction and repair generally of highway, road, airport runway. Another, the maritime setting, you can say, due to its high resistance to salt water, geopolymer concrete may be used for the concrete structure that will be under constant attack from salt water. So salt water is again danger for the same. So geopolymer concrete is also much more suited than ordinary concrete to be used in cold climate. That is one thing. Because of its high resistance to acid and toxic waste, geopolymer concrete can be applied in various highly acidic and toxic environment. High density concrete is concerned, that is again that name itself you do understand that is more than 2400, or it can say more than 2600, and it's density concrete made with some commonly used high density aggregate are given following table, means it is given with the table immediate, so we can just put thought that what is existing type of aggregate is listed left hand first column. second specific gravity value, bulk density value, and then overall result in concrete density. Ranges are given because of we are not sure how much percentage of the coarse aggregate, fine aggregate, everything is again depends on by experience only. Let me again clarify or inform to house that mixed design any software is introduced till date. So many regions are there. That's why because of that ingredient itself vary with region to region. Environment condition also vary with region to region. Even for mixing procedure also sometimes vary, place to place and placing and then curing. So many things are there to get the proper proportion or proper strength. So that is why what people have worked some case study, prepared the Excel sheet and calculated the things, standard deviation, everything they have taken care. Exposure condition is also mentioned clearly. However, I told that during execution also important. Even batching plants should be calibrated in such a way that it should give the correct value of the material. Sometimes it may not. Only we are very much relying on number, digital. It is showing 25, but exactly it is going 27. Suppose. Then it should be time to time calibration of the batching plant also very much required. Otherwise, resulted concrete may not work properly or give some different values. Ultimately affect on strength. So here few are there, ferrophosphorus, even magnetite, hematite, and other things are written. Scrap steel also are to be used. So these are the typical things need to be added to prepare the high density concrete. And usually we are not using for structural concrete routinely. High neutron and gamma ray, where it is to be used, specific structure. Good mechanical property is there, relatively low initial and maintenance cost, easy to construct. So these are the main advantage. However, disadvantage also attached. That is, more space is required because of every ingredient have own dimension, own density. So finally, it require more space. It's heavyweight concrete, so difficult to handle also. And but natural, you have seen in last slide that this type of aggregate you have to specifically put the order, get it, and that's why it add the cost. So that's why it is written. It is resulted into high cost. So that's why. But still, whenever it is required, it is to be used. I mean, it is to be put order and forget about the cost. Application I told when high density radiation shielding is there, precast block sometime, mass concrete project. Even I have seen the WARF block, WARF, WARF block to break the water nearby jetty. So that kind of block also you can prepare. So that is mass concrete project is different. High density concrete application column also sometimes gravity seawall, yeah, coastal protection, and this I was telling you about the breakwater structure. Bridge counterweight, then ballast for ocean vessels, and offshore platform noise and vibration dampening. So I think that time we are using such kind of just now this is very much you are knowing fly ash, usually color gray, not that much whitish also, and you can say it is a byproduct now we are calling. I told it is again industry waste. Coal based industry is there to produce the power which will produce the fly ash. So people have worked very initial 10%, 20%, or more than that also. So that is we can say more number means high volume. Fly ash, a principal byproduct of the coal-fired powder plant, I told, is well accepted as pozzolanic material that may be used either as a component of the blended Portland cement or a mineral admixture in concrete. So very beginning to produce the cement itself they are adding along with cement, or otherwise you can do later on while preparing or mixing. In commercial practice, the dosage of fly ash is limited to 15 to 20% by mass of the total cemented material. Usually, this amount has a beneficial effect on workability and cost economy of the concrete, but it may not be enough to sufficient improve the durability of sulfate attack and alkali silica expansion and thermal cracking. So these are the big words, you can say sulfate attack, alkali silica expansion and thermal cracking. So I think this is related to durability only, and sulfate always there. So it will again create reactivity, that is attack, you can say, because of beyond its in attack regions, it again create cracks. HVFA, that is high volume fly ash, generally we are replacing minimum 30 to 60. Remember, up to 60% people have worked. However, those fly ash is properly, you can say, refined, or you can say modified. Not directly raw fly ash cannot be used. Remember, so this fly ash is again you can say processed. Few company are there, they are also making good uh, process of the fly ash, and then they are selling. Water binder ratio, the Y binder, because of your cement also there and F also there, fly ash. So C plus F, B stand for. It must be less than 0.4. Very low water, chloride and oxygen penetrability, almost double design life compared to traditional concrete. So that is things are available in literature. This is based on literature. It is mentioned the all, you can say, points. Better finishes we are receiving, better fresh concrete property also we are receiving, does not affect the schedule of construction, economical than conventional. That is also very great thing. That, but however, very initial cost always there. Offer sustainability of depending resources. That is again uh, very much important. The education is important. Remember, you have done very good way mixed design and keeping all parameter ideal. But on site, what happened? That temperature, humidity may not, you can say, may fit with that what you were assumed. So sometime engineer in charge has to take decision, and then modify the things, and proper education should take place. Advantage of the HVFA is adequate structural strength we are receiving, improved flexural tensile strength also we are achieving. Because of presence of high volume, definitely it will reduce the bleeding, and very cohesive mix we will receive. It also resists the sulfate and other chemical. This is proved item. Let me clear. Provide fly ash and this C means cement should be proper. They added properly, mixed it properly, placed properly, cured. Then these are the comes. Anywhere sometime one thing is missing or not properly done, definitely this point is not valid. It will affect cost list, definitely, because 50% you are using fly ash and 50% you are using cement. And environmentally sound, because of it will not react if you are using by hand, gloves also there, but still it will not harmful like geopolymer. However, disadvantage also listed. All fly ash cannot be used in structural website. That I very much clear about first line that fly ash 60% is good, but not as a raw form. Every plant, vary its property, plant to plant. So that's why even I think you could have heard that IS 2185 also existing, and you can say C flies is there, F type flies is there, which flies? It is again classified, and in between, because of there is a chance. So depends on, and the production of the flies itself depends on properly maintained the manufacture plant of the those where it is produced properly, you can say taken. Require good knowledge of mixed proportioning, because of mixed flies again having a more surface area than OPC. Second, density also lesser than cement. So when you are calculating or mixed proportioning, its specific gravity need to be considered. Its, you can say, density should be considered. Don't blindly take say 30% means you have to, while mixed when you are calculating mixed design mixing, then its other property need to be added, right? So you can say 30%. So 100 kg is there, 30% means 30 kg is, don't take directly, remember that is again with respect to total composite, what is the resultant density. So I think everything nicely given in the case of calculation in IS 2019, I mean 10262 and 2019. Very good calculation. I mean M40 or M30 is given. So you can have the time, you can look at require better, and then they have used this one flies. Slower rate is for hardening because of composite, I mean which not all of a sudden get CSH gel phenomena. It takes time, so that's why it is having slower rate of the hardening. Behave differently to stream curing. So this is one thing is there. So whenever hot country is there, steam curing means, I mean it is different thing, but if it is cured through steam, then its behavioral part will be different. That is meaning, and it give good setting, you can say. Require good curing for minimum 7 days. Material also I told it requires cement, fly ash, water, even entrapped air, coarse aggregate, fine aggregate. Use of HVFSC is very suitable for tropical and hot climate countries like India. It can be effectively used in structural and non-structural application where normal concrete is used. HVFSC wins over normal concrete in most technical parameters. So high performance concrete, high strength you could heard, high performance, and then ultra high maybe the last. So high performance concrete is again in an engineered concrete for possessing the most desirable property during fresh as well as hardened concrete stage. HPC is far superior to conventional cement concrete as the ingredient of the HPC contribute most optimal and efficiently to the various property. Now HPC is concrete in which the certain characteristics are developed for a particular application and environment so that it will give excellent parameter or performance in structure in which it will be placed in the environment to which it will be exposed, and with a load to which it will be subjected during the design life. So it is a long sentence, but what I wanted to say that it will again create good, I mean compatibility. That is the things. Material as usual, what we are using in traditional concrete, but in addition that mineral admixture we need to add, chemical admixture we need to add for maintaining its rheology property. The advantage is concern reduction in member size resulting in increase in plinth area, usable area, and direct saving in that concrete volume. Saved. So what is happen, high performance concrete you are used, it means that it will have very ideal kind of things you are consider, and I mean ingredient is concerned, and it will increase the strength. Same time it will also work any uncertainty induce. That is the meaning. It will perform during any uncertainty induce. Maybe environmentally, may temperature sudden rise or decrease, windy is there, cyclone is there. So that is the meaning. So that's why it is written high performance concrete. And because of high strength, it will, you can say in traditional concrete it is 230, suppose number is there of the width, but here and 450 may be there, but here it is required less both dimension, and then you can say you are saving the those area, and functional area can be increased. That is the meaning. Reduction in the self weight and superimpose means dead weight with the accompanying saving due to smaller foundation. So I think it is written different way how we can, optimize this advantage. Reduction in homework area, because of, I think that is also sometimes happen because of, dimension are to be used less, so less dimension of the homework is required, and then accordingly otherwise you can soaring and stripping time also reduces, or you can say cost will be decreases. Construction of the high-rise building with the company saving in real estate cost in congested area. Low creep and shrinkage. This is very important. People never thought about this. Is again, both are known as time dependent property, creep and shrinkage. So we should think for that, for because it vary, each concrete, you can say different concrete. So creep and shrinkage is again very much durability aspect, time dependent property. One has to work and give the those model for creep, and I mean it can be predicted also for it vary. I told concrete to concrete, types to types. Longer span and fewer beam, the same magnitude of the loading. Reduction axial shortening and compressing supporting members. Reduction in the number of supports and the supporting foundation due to increase in span. Reduction in thickness of the slab. This I told that slab thickness and dimension you can keep lesser than traditional concrete. So weight will be minimum than previous or with respect to traditional concrete. So ultimately cost of structure also reduce. Superior long-term service and performance under static and dynamic fatigue loading. Greater stiffness as a result of higher modulus of elasticity. So this is again this EC nothing but composite or concrete modulus of elasticity. We usually assuming that elasticity of concrete is this, M20 is this, then this general formula is given 5000 square root of FCK. But that is general, very general. It may not do. It will give conservative things value. So for for higher strength, this may not be work, right? So people are working for that to get this standard curve for the high strength concrete. Higher resistance to creep because of that is valid for conventional concrete. Now we are working in special concrete, and as per feel the our need, you can say. So that's why we have chosen the special concrete. So for that its behavioral part is not exactly same as good as traditional concrete. So we have to think for that. We have to again think for its durability, think for its again other parameter, creep, shrinkage I told, and other dimension, that is capital E. It reduces maintenance and repair. So this is just, I think, okay. And smaller depreciation, fixed cost, that is also written, but disadvantage always there. High performance concrete means powder content is more, cement content always you have to keep more. manufacture and place much more carefully more than normal. That is one thing. Skill thing is required. Extended quality control is required in concrete plant, and at delivery site additional tests are required. These increase the cost. Some special constitution are required which may not be available in the ready mix concrete. I think these are the just sake of written the advantage, disadvantage. Application you can say mainly used for the case of bridges, high-rise building, tunnel, pavement, and nuclear, where mass concreting very important structure are there and these is to be used. That is importance. Ultra high, it is just one step ahead. Then you can say still it is very much costlier than previous. So I think then cost may not be considered, and I think these are the statement or tax has been written. Sometimes its strength will achieve up to 200 MPa. So I think this is what you have to, I mean, I will not discuss, but material also cement and here special, if we are talking ultra high performance, then C3A content significantly lower. So the C2S, C3S, C3A, C4AF and something 4 component as concerned, and everybody must be clear about the cement chemistry, that I hope. So all 4 components play key role. Ranges are given. However, that ranges also vary with respect to your product. So here C3A content significantly you have to keep lower than what is available in OPC. That is so. I mean, special kind of cement is required. That is indication. Then fine aggregate to cement ratio or sand to cement, it must be 1.4, or then you can say maximum size of the keep 0.8 mm. Remember, 1 mm also not they are allowing. It means that there is no coarse aggregate, right? But with respect to that, we are supposed to use silica fume, then glass powder, high range water reducing agent is required. Water and cement ratio should be 0.22 and steel fiber at 2.5% by volume. So these are the things. See, it is not directly written. See, each point is again so many hypotheses, so many research has been implemented, and certain ideal condition. Remember this: if you are taking same and preparing the mix, I am sure it may not be. Here ranges are there, and that environment is same. Then definitely it is to be manufactured, but it is not happening at all. When you are calculating on piece of paper and you are providing mix proportion and you are doing, sometimes you will not get good cohesive mix, and sometimes workability may be issue. Later on durability or strength criteria will not meet the requirement. But let us accept that we did all in ideally. That's why you can say it's ductility or ability to support tensile load. Even after, because why see here you can see the one more thing. Last one is very important. Steel fiber at 2.5% means steel fiber, that is steel means discrete steel fiber. Remember, along with continuous fiber, steel bar, we have used steel fiber also. Overall, not only beam column junction, everywhere. So it means that whenever tension appear, it will resist. Extreme durability, low water to cementous material ratio, that is one advantage. Self consolidated and highly moderated. So it is, I cannot say it is SCC, but nearby SCC, because of here also you can see the our size of aggregate is 0.8 mm and other thing. So that's why it is special kind of mortar itself, I must say, but it is purchasing, I cannot say concrete mortar, but it is concrete. High quality surfaces, flexure tensile strength ratio up to 40 MPa, remember. So through fiber reinforced concrete. The as per American Concrete Institute reading are given, whatever is I have written, and it is proved items. Here what advantage? It is a thinner section, longer span we can keep, lighter weight will be there, new graceful product, geometries are there, chloride impermeability also there. I think RCPT word you could have heard. So that is mainly for to get the weather, how much you can say erosion taken place, or you can say even carbonation can be done. So here chloride is introduced due to presence of the salty water, and even that fine aggregate also having coarse aggregate also having alkali aggregate reaction. Then finally chloride it I mean allow to penetrate. If not, then it is good. So impermeability is required. Abrasion and fire resistance, that is very much important. Abrasion resistance, you would have heard IS 1237. Abrasion is mainly applicable for the tile, but same phenomena can be adopted, same specimen for the concrete also, and then you can get the some relative value of the abrasive mass of the that concrete, and that same thing can be applicable. Of course, different method also as per American Concrete Institute is available. Fire resistance also play key role. Fine. No steel reinforcing bar cages. Then minimal creep and shrinkage after curing. Optimum mix proportion. So I think these are the things which is I was talking about this word in previous slide. That is self-compacting concrete. I think self itself, you can say itself due to gravity, it will go its respective place. That is the physical meaning. Now, it flowing concrete mixture that is able to consolidate under its own weight. That second, the highly fluid nature of the SCC make it suitable for placing in difficult condition and section with congested reinforcement. Use of SCC can also help minimize hearing related damages on the work site that are reduced or induced by the vibration of concrete. So here additional vibration is not required. That is the physical meaning. Another advantage SCC is that time required to place large section is considerably reduced. I think that little what is available that is mentioned. All special concrete I have given just glimpse only. Its design criteria are again need to be discussed properly, and because of I told that every material have own property of the maybe in terms of the specific gravity, in terms of the water absorption, in terms of the shrinkage, creep, and density. So here silica fume is again one of the material. It is sometimes called micro silica, sometimes it is called condensed silica fume, volatilize, silica or silica dust. Basically, it is byproduct of smelting process in the silicon and ferrosilicon industry. So this is again byproduct, but now people are again making process and then it become very good silica for the construction purpose. It is usually a grey color powder, somewhat similar to Portland cement or sometimes fly ash. It can exhibit both pozzolanic and cemented properties. Silica fume has been recognized as a pozzolanic admixture that is effective in enhancing the mechanical property to great extent by using silica fume along with superplasticizer. It is relatively easier to obtain compressive strength order of the 100 MPa to 100 to 150 MPa in laboratory. So I think this is nearby, not ultra high, but it is like this only. Higherly compressive strength we will receive if we have used the silica fume. High tensile flexural strength and modulus of elasticity. Very low permeability, I think. Enhanced, durability, increase the toughness. Toughness word we have not used at all, but toughness is again one of the resistance against the loading, you can say, or transverse loading. That is beam or any point load or UDL or combination of the load. Increase the abrasion resistance on the deck, floor, overlay and marine structures. Superior resistance to chemical attack from chlorides, acid, nitrite and sulfates, and life cycle cost efficiency. Higher bond strength and high electrical resistivity and low permeability. Advantage also attached over here, since it has high surface area. Silica fume increase the amount of water needs in the mixture. Another disadvantage to utilize silica fume in the cement is the cost. Silica fume cost, it is given in dollars, so I think we will convert into our currency. When using this or any other alternative cement material with Portland cement, it is necessary to create trial mixture to ensure proper proportioning for the desired property. So application, just you read, I will take pause for 2 minutes.
Hello, sir.
Move on.
वो आपका ओरिजिनल लिया लेके आया था ये अलग है ये आपके आपका तो भी बड़ा होता है आपका So here application, now please sorry for delay or I mean this interruption. High performance concrete, high strength concrete, high silica fume shotcrete. These are just fundamental application where we are using that concrete. For repair product also we are using refractory and ceramic kind of things. I was showing that time, just it is available here. This kind of floor or you can say block is available lightweight. It can reach by single man, so it directly reflect low density kind of material. Double AC block is like that only. Structural lightweight aggregate concrete is an important and versatile material in modern construction. That is just fundamental. It is written. It has many and varied applications, including multi-story building or flame, floor, bridges, offshore, oil platform, pre-state or precast element of all types. Many architects, engineers, and contractors recognize the inherent economy and advantage offered by this material, as evidence by the many impressive lightweight concrete structure found today throughout the world. Lightweight aggregate concrete can be produced using varieties of the lightweight aggregates. Lightweight aggregate are originate from either natural material or the thermal treatment of the natural raw material like clay, slate, or shell or leca. Something is written. So it is related to very low weight where thermal treatment power plant is concerned. So manufacture from industrial byproducts such as fly ash item, then processing of the industrial byproduct that is slag kind of thing or otherwise GGBS kind of things. Advantage of the and disadvantage: reduction in dead load, making saving in foundation and reinforcement, improved thermal properties, improved fire resistance, saving in transporting and handling precast unit on site, reduction in formwork and propping. So I think it is very much self-explanatory, and we will not discuss. So this is the pervious concrete. Pervious means it allow to water, penetrate. It allow to water. It can drain easily. That is the meaning. So pervious concrete contain narrowly graded concrete aggregate, little to no fine. Severe sand they are not using, and insufficient cement paste to fill voids in the coarse aggregate. This low water cement ratio, low slump concrete will be resembling the popcorn is primarily held together by cement paste at the contact point of the coarse aggregate and particle. This produces a concrete with a high volume of voids and high permeability that allow water to flow through it at rate of 81 liter per minute. So I think it is permeability is given. The compressive strength of pervious mixture typically now it is very low kind of strength, 2.8 to 28 MPa, not more than that. So I think pervious concrete is used in physical hydraulic structure as drain media, parking lot. Mainly parking lot is we are knowing pavement you can say, and airport runway to reduce storm runoff. It also recharges the local ground primarily by allowing water to penetrate the concrete to the ground below. Pervious concrete have also been used in the tennis court and even greenhouses. As a paving material, pervious concrete is cracked or slip form into place with conventional paving equipment and then roller compacted. So I think pervious code also with respect to ACI 522R recommended, right? So I think this is just details for the same. Pervious concrete is used in building construction for its thermal insulating property. Basically, remember thermal, for example, 250 mm thick porous concrete wall can have R value, zero point 0.9 and compared to 0.125 for normal concrete. So pervious concrete is also lightweight. Its density can look at not beyond 1900, and it is also showing that low drying case property. Current studies in SCC which are being conducted in many countries can be divided into the following categories. Use of rheometer to obtain data about flow behavioral of the cement paste and concrete. Mixture proportioning method for SCC, then self characterization of SCC using laboratory test and so on. I think this is a vast self concrete. RMC is now very much you can say familiar. Better perception from customer by offering a technically advanced higher value concrete mixture offers product that saves customer time and money, faster truck turnover around, more efficient use of mixing equipment and delivery. So I think this is the related to those SCC related thing is given. Only disadvantage is there. People don't have the understanding of the limit of flow distance of the concrete in order to avoid segregation of force. Higher rate of casting with SCC could compound the problem of excessive formwork pressure. So here basically one requirement is very airtight kind of formwork is required. So slurry should not go out, and you can say that is again cost effective. Again, if you have not properly designed, then there is a chances to remain or induce the bleeding and segregation. This is the only uh, disadvantage. Self cleaning concrete is again nowadays people are working or available. You can say basically it is a photocatalytic concrete, and maybe may sound futuristic, but it's already being used in part of Japan and Europe. Self cleaning work by adding a catalyst kind of thing, usually titanium dioxide or fresh concrete mix. Titanium dioxide activity activates in the hardened concrete when exposed to the sun. The activation changes titanium dioxide electric charges, causing a repelling effect. Here what happened? Repelling effect will be there between the concrete and dirt and pollutant on the concrete surface. So this is again, if you have used surface on this kind of concrete, then directly it get clean. Another kind of concrete is translucent block are made by mixing glass fiber and acrylic road or optical fiber to make concrete allow light to pass through partially. This is just decorative kind of thing. We can not structurally, but it is existing. Chronos concrete, a project by Chris Glister, Efsin Mehin and Thomas Rasen at the RCA Innovation Unit London, use heating element and link ink to allow graphics, word and number of to be displayed within concrete. So I think this is also already existing. Heat sensitive concrete. This is now people are working so far as Surat and even whenever Chennai, they are using this kind of concrete. Or, I mean, research is going on. That is textile reinforced concrete, a composite construction material consisting of the finely grained cement-based concrete matrix and high-performance continuous, multi-filament yarn made of the alkali resistance air glass, carbon or polymer fibers. So this is one of the composites. Has high tensile strength and quasi ductile behaviors. The TRC composites tend to be slender, lightweight, and capable of being designed into complex geometrical shapes and configuration. Another, light transmitting concrete. Lucon is the new breed of light transmitting concrete. Unlike other versions that use acrylic road or optical fibers, Lucon is made of the translucent fabric cast layer by layer into fine-grained concrete in prefabricated mold. So I think this is again related to that. 3D printing concrete also people are doing that, even not regular ways still in India is imposed, but even concrete printing sound like something from realms of science fiction, but it's very much today innovation rather than tomorrow's one. So research group at uh, Lafargue University, led by the Dr. Sangu Lim, has developed a 3D printer that is able to build physical object directly from the computer generated. Known as additives manufactured concrete between such example whereby a specific type of concrete which has been developed for the process will deposit in layer very precisely under computer control. So look at what is necessary to print concrete. One is design freedom. Here what happen? We will have design freedom. You can mold any shape, and then sustainability. That is also important. Nano additive is also one of the material that is ultra fine additives, reactive with particle size in the range of micron to nano level are found to be useful in enhancing performance of the HSC. Nanosilica, the most explored admixture, is found to result in high early strength with a greater pozzolanic activity. Ultra-fine carbon active additives such as graphene oxide has shown promising enhance in HSC performance. Right? So nanofibers such as CNT, carbon nanotubes are capable of the arresting microcrack and their propagation very effectively and contribute to overall performance of the concrete. Bio-based product. फाइल तो है ना यहाँ फाइल है ना
अटेंडेंस की फाइल पे
इसी टाइप का था ना
हाँ जीआईसी से लेकर
brick made from bacterial by product that mix cement and particle just 1 minute. Just so bio-based product also important. So brick made from bacterial byproduct that mix cement sand particle. So another product in work is bacterial, infused concrete that reportedly fills in the hole and crack in the concrete, making it last longer and reducing the maintenance cost. Now, what are the challenges for the future world? Mainly, you may say 80% of that will live in urban environment. You may say then majority live on coastal area, leading to development of massive, infrastructure, urban infrastructure. More concrete jungle will be there, that urban floods, urban heat highlands, powerful, typhoons, considerable damage to the life of the people, that is impact on social and environment condition, and finally what is existing, that is global warming. So these are the challenges are there. So call for achieving sustainability. I think sustainability word since long we are hearing sustainable development. What is it basically? What you are manufacturing, what you are picking technique or structure or material, it should be sustainable. It should be sustainable. Its meaning is that it should work with durability aspect. And durability is vast word. It relate with temperature, relate with penetration, work permeability, and in load wise you can say any earthquake, maybe snow load, maybe wind load, like that. Everywhere that material what is involved in that structure member, it should perform well. That is the meaning. So sustainability is again required. So sustainability needs basically what happened, impact of construction. Now this is again very understandable that it consumes 40% of the world energy. When we are doing this, then construction is, this is with respect to construction only. When we are doing construction, it consumes up to 40% of the world energy. Remember, it contributes the displacement of the most productive land very much, then contribute to 30% of the global greenhouse gas emission. Then contribute means adding, remember, not positive manner. Contribute to loss of, this is the sustainability requirement. Contribute to loss of biodiversity and ecosystem. Fourth one causes 10% of the world's emission of the fine dust. Even fine dust also creating problem. And most widely used material after water. So these are the thing 1 meter cube per person per annum. So this thing I have taken from American Corporate Institute magazine, and it is well documented, and just giving the thing that what is the impact of the construction. So sustainability in common sense, you can say, define the meaning, the need of the current generation without compromising the ability of the future generation to meet their need. Remember, this is the sentence of definition. Another, sustainable construction is the practice of the creating structures and using processes that are environmentally responsible and resource efficient throughout a building life cycle, from siting design, construction, operation, maintenance, renovation, and demolition. So I think this cycle is very much understandable, and so I think meaning of the sustainable construction is very much convey this from this long sentence, and sustainably also given definition. Structural efficiency meaning is what? Energy efficiency, water efficiency, and material efficiency. Efficiency is general word, but it relates with structural. Then what is meaning? To minimize the environmental impact associated with all life cycle. Second, energy. Reduce the operating energy use. Energy you are using minimum compared to traditional. And water efficiency, reducing the water consumption, that is the meaning. Material efficiency, material should be renewable, recyclable, and environment friendly also. So I think these are the fundamental, or you can say principle for sustainability building. We will work or talk with respect to building only. So these are the 4 parameters. One is structural efficiency, what you are producing the structure, it should be, minimize the environmental effect, it should not create impact on environment, right? Energy efficiency, water efficiency, material efficiency. And new concept we can look or add, that is rheology instead of workability. What is the rheology? What is yield stress, not slump? And this stress means shear stress. Rheology is concerned. Blended cement instead of the OPC. Durability instead of the strength. And long-term performance instead of 28 days. We can say it may be more than 1 year or more than 10 years, something like that. That is long-term performance. And performance-based design mix with locally available material. It varies. That's why I told that this design makes also vary region to region, person to person, experience to experience, and that's why performance-based design mix must be there. With locally, you are talking that mix Surat, then talking at Jammu Kashmir, talking at somewhere, Chennai. So I mean, it vary definitely. That is the meaning. And accordingly, design mix need to be prepared. Engineer the structure rather than just build it. Right? I think it is convey the meaning. And selfing concept. So selfing concept is, again we will discuss. Now because of COVID-19, what will the impact on concrete industry? In this one slide I want to talk. The COVID-19 outbreak has slowed construction. In many countries, the industry has seen lower demand for its product and leading to overcapacity. Second, cement companies are largely expected to survive this crisis, but they must strengthen their sustainability and competitiveness. Companies must also reduce their carbon emission for their long-term viability. with the cement sector generating 7 to 8% of the global greenhouse gas emission. And pressure is growing for the industry to achieve carbon naturally or neutrally. Carbon neutrality. So I think with this, just this new concept, we can have 10 minutes. I will discuss selfing concept. What is selfing concept? So concrete start gaining strength. So the instant of time since water is added to dry mass. If it is not placed immediately, it starts losing its strength. Not placed in particular structural member. It is very difficult to alter concrete one place. Once it is placed, then you don't it will not in your hand to you can alter it. If the partially set concrete is used in structural element, it reduces strength seriously dangerous the stability of the whole structure. So I think selfing is what still I have told in a few minutes back that it is a we are looking or talking or understanding the behavioral part of the delay mixing. So sometimes we can say it is partially set. What is partially set? Excuse me. So concrete develops strength in presence of water added to the dry mixture. Second, the instant time is term suppose 0 hour. It means that you consequently the freshly mixed prepared and can be termed as a 0 hour mix. 0 hour mix means fresh mix. You are not you have prepared and within few minutes you are within the limit you are placing the mix. That is the meaning of 0 hour. But the time interval between the preparation of mix and casting of the mix or it is a placing of the mix. In mold, suppose if you are talking in laboratory, then mold may be termed as time lag T, right? So some time maybe 30 minutes, then it is called T time is 30 minutes. The mass prepared T0 but left, suppose you have already prepared, but because of it exposed to time lag T, until molding will term as T hours. So T hour mix is means it is a old mix. You have already prepared, but same time mold was not available. It is not within your limit, and then it came after 30 minutes or 1 hour. So those mix now I will call old mix or partially set mix. So now it must be clear what is zero mix. It means fresh mix. You are within a limit time limit you are placing in mold, but you are taking time to place the mold, then it is old mix or consider partially set mix. Now why this study is required basically very interesting. You can read also. In field concreting works, it is often experienced that due to unforeseen circumstances, as mentioned below, mixed concrete mass undergoes setting before being placed into the formwork. So displacement of the formwork, breakdown of the machinery, these are the reasons. Power failure when concreting is going on, then accident, then stoppage of the work due to strikes, etc. So these are the fundamental 4-5 reasons. There is a chance to get delay in place. At the time of passing the partially set T hours concrete, that is THC, become unserviceable. If it is more, then it is not advisable to use and it is often declared as a waste. Second, the question arises to what to do with huge amount of partially set mass of concrete. Should it to be discarded, total waste, or is there any way to gainfully reuse it? These are the questions. This problem can be efficiently handled with the help of the very strong and reliable mathematical tool known as selfing concept developed by very recently. Selfing is in terms applicable to the blending of two individual mix of the same mix, but type mix type, but of different R and T value. R means what happened? R is ratio of old mix to fresh mix. Crossing is term of applicable to the blend mix of the two different individual mixes of the different mix type. Now it must be visualized. you can see what I wanted to say. Now put in graph form, or just like x and y. X axis we have taken time, y axis we have taken dimension strength, 0 start to t. Look at phase, one row is there, then blended means it is mixed, and old. O means 0, 0 is again having A0 and B0 practically same. A0 is suppose consider now namely M20, and you have started at 9 a.m. Similarly, other mix also you have prepared simultaneously, that is also 9 a.m. in different platform. And now you are mixing, so definitely you have not made any set, you allow to set, and you have used same time both mix. So that is called 0 or T 0 hour mix. But you can look at T1 time is there. Here, this dashed line known as strength. Say here I can say A0, B0, C0, something like that. Will you guys say M20 is there, then here I should get 20. That is the meaning. Now, if I have given time for that, A0, and now it become A1 mix, here M20 mix, and again M20 mix you are prepared, and you mixed. You have taken mix some amount of the B1, and this is the composite mix. Now due to time lag, T1, here strength will be at, here A1, but C1 also there, B1 also there, and A2 is there. Then here, now let me clear. First line, dashed line known as fresh mix line. Here M20 is there. Here 9 a.m. you have prepared and placed, and after 20 days you are getting same value. Now you have done at 10 a.m. 10 a.m. same mix. So you will get also same mix M20 only. So I mean you are immediately you are using, then it is get. But now intensely you have prepared at time A0, but you place at T1 time, then it will be reduced. So this is my curve. This is one curve. First curve is R0, second is something R value. Third curve known as B2 is written, means it is a infinitive curve. Remember, R is what? Quantity of old mix divided by quantity of fresh mix. Here R equal to also same ratio. Here first R quantity of QO upon QF. QF is always there. Old you have not, it is allowed. So 0 by QF means it will be R is 0. So here R is 0. And here last curve is indicate quantity of old mix upon quantity of fresh mix. So here phase you are never use. Just here you are prepared and you are casting at this moment T2 time. So then it become this curve, bottom curve. Forget about intermediate. It is some R value in between. So this is R QO upon QF, where QF is absent, QO only there. So something divided by 0, it is infinity. In first case, QO is 0 by QF. QF is present, quantity of fresh mix. And last one is quantity of old mix is present all the time. So these are the curve, fundamental curve. Now you can again consider same mix. I have told that quantity of O and quantity of fresh mix. This curve itself directly indicates quantity of O, quantity of. Now I am taking one arbitrary value. PQR is there. So my basically this bottom curve is infinitive curve, and other curve is R equal to R something value. So horizontally if I do, so this horizontal, and then it intercept in this curve, namely it give a infinitive t. This is my now strength. I have parameter taken a symbol, and t time taken is small t is elapsed time. So you can look at the alpha pq upon pr. So here a infinitive t dash is there, and here a r t. There are two variables. One is r is ratio of this one, old mix to fresh mix, and T is elapsed time. If T dash is come, here RT come, and vertically ERT and PQ. Here this curve known as infinitive, so A infinitive T. Here it will give A infinitive T dash. So this dy by dx kind of thing you can do slope PQ upon PR. So A infinitive ERT, A infinitive like this. You can have the P and Q component. The E means strength. Strength may be compressive, maybe tensile, whatever is there. But let us consider compressive. So my PQ component strength increment will be ERT minus A infinitive T. This is minus this ERT minus A infinitive T. And bottom T minus T dash you will get PR is concerned. Then you can have the further it is your study of the first year or any mathematics, then this is become partially difference differential equation, and solution for that. See, any particular value of r art become only function of t. So this I have written this way: t plus at upon ast equal to c. So now this solution of this equation number 4, C1 is another arbitrary constant, and again after applying the boundary condition, T become Ti. Ti means initial setting time, so AR. T become TF, then ARF, and this is the my things will come. So I think what I wanted to convey through this mathematical modeling, you can have the, I mean, different value of R, different value of time. You can predict. Your truck is suppose started 9 a.m. but after 10:30 you have place. So what will the reduction in strength will be taken place, or how much need to be add the fresh mix from this equation? So I think we are ending, and here case study we have done. For that now setting time of concrete you were never heard, but setting time of concrete we have to find out with the help of penetrometer. So this is the work carried out by one of the PhD student. Now we reach 10, 12. So up to how much I have to go? 12:30 or 12? Hello? Anybody can respond? Oh, can you hear me? Hello?
Yes, sir, it is hearable, sir.
Okay. So
Sir,
to how?
sir,
Now,
only time is has already been done, sir. You have taken much more, sir.
Time is over, na?
Yes, sir. Completed, sir. Completed, sir.
Okay. So I mean, this I will send a PDF format to you, or this same
Definitely.
PPT.
Definitely,
You can
sir.
share with your participant. Last
Sure.
one I support to keep first. Actually, it is very time-consuming job to understand the selfing phenomena. But it is in fact
Definitely,
kept
sir.
last
It's
one.
actually new one to understand to all the participants, including myself also, sir.
This equation is developed, and I mean ERT means suppose strength sigma ERI. This is let us sigma consider as strength of the compressive strength. Sigma RF strength at initial setting time, strength at final setting time minus initial setting time. T we have taken in between. Suppose final setting time is 5 hours, initial setting time maybe 2 hours. So 5 minus 3, 5 minus 2 suppose. But I want to know my strength at that time at 4 hours how much. So that is the prediction of the these two variables. So I think this I will again discuss whenever time permit. But I think this is very on this one book also available, written by my guide Dr. N.K. Bairagi, Selfing Concept of the concrete. And even plate also same thing is available, theory of plate and self. So anyway, I think I have taken much time, and thank you for uh, remain present, and thank you for giving a chance to interact with you. In fact, a little throat problem is there, so I am just sorry for that. Sometimes I have intentionally kept pause for 2 minutes, and maybe loudly or not properly loudly. Sorrow for that. I mean sorry. And now discussion. Any
Sir, your
there?
voice is perfectly clear, even though your thought is not clear. You have devoted your precious time over here in this FDP. This is much more important, sir.
Thank you, sir.
Even though you were in journey yesterday and you just came early in the morning to take this particular expert session, it is really proud for the GEC Dahod and for me also, sir.
Thank you.
Now, all the participants, please, if you have any questions or doubt, please share over here through the chat box as well as through the WhatsApp group. So we are eager to hear you if have any questions or doubt.
Yeah, because of with respect to title, I did it. Otherwise, many case studies are there. Only one concrete or two concrete combination. But here it was, fundamental means at least I already beginning declare that it is a vast subject, concrete technology. So I try to make it, all gist I have given kind of things. Now, still so many query must be there, I am sure, but if you can raise your, hand, I will try to compliance it.
Sir, there is one question from the participant that if old storage of flash is used, whether it would affect the strength of concrete?
Yeah, definitely. So even when you are doing research, forget about flies, even cement also there. It should be properly, stored where air should not come. You can say that it should be airtight, kind of things need to be stored. So flies also definitely it affect. So it should be properly, storage is required. Even I told I did in 97 to 2000 at IIT Bombay. In those days also I have used those kind of, plastic drum airtight. I procured from some of the company, and it was even at a time all batch or I mean cement were stored. So that's why different batch also not create problem. So whenever you are starting problem or experimental work, material should be from same batch. That is very much required. So that's why storing is required. I mean very beginning, including coarse aggregate, fine aggregate also, right?
Thank you,
So
sir.
because of it also attract with HR, what is called RT, relative humidity, RH,
Sir, another
and
question.
uh,
No, you may continue,
yes,
sir. You may continue, sir.
hello.
Sir, there is one question there that by
Hmm.
applying selfing, what benefits we will get?
Yeah, definitely. That benefit I already told that suppose truck is going, 10 truck is going, and one accident taken place, they are not reaching to say, consider one Kevadia colony. Now it is completed, but just sake of, taking same example. Now contractor don't want to throw out this, their material. Even 1 hour is passed. We are knowing that M20 have say 3 hours is initial setting time, final is 6 hours, and now 1 hour is already passed. So but we know that because of that concrete already taken place, CSA gel phenomena induced and hardening taken place. So contractor knowingly or unknowingly adding the water or sometimes cement slurry and make it workable, but he is not sure. So in that case, first of all, my equation will give the prediction of the strength. They now say instead of say that is M30 earlier it designed, but now it is giving M21 only. So 9 MPa gap is there. So to make it workable, some other cementous material and additives to be used instead of thrown out, it made again workable, and that is the advantage. Otherwise, whole 10 truck will be discarded. Basically, it should be discarded, but with the help of this knowledge, if we are knowing M20 and M30 or any mix, its initial setting time and final setting time that available method to determine the setting time. We know the setting time, that is PRM method, penetration resistance method, and those things we are knowing, and then we can predict that this much reduction taken place. So to overcome that, you decide the other proportion at that time only. You add the some slurry of cement, add the other additives, make it again mix and workable, and then it will definite, that is called crossing. So selfing and crossing concept is definitely helpful to predict the strength and to enhance the strength. In fact, cost will be increased. Instead of discarding, you can say you are utilizing those mix. That's right.
So thank you very much to enlighten us by this new concept. So there is no more questions from the participants that I have been seen right now through WhatsApp as well as through the chat box. So on the behalf of the participants, on the behalf of the Government Engineering College Dahood, and on the behalf of me, as you are my guru for PhD, so on all level, I am thanking for you to spare the time over here. Thank you very much, sir.
Thank you very much.
So I say you may relieve, sir.
Yeah. Okay. Thank you, one and all.
Okay.
Once again, thanks to organizers, including principal and HOD of the applied mechanics. Thank you, even dear participant. Without you, I cannot talk. I cannot deliver the lecture. Thank you, one and all.
Now, all the participants kindly request that the second session will start at 1 o'clock. So till then, we have a break. Thank you very much.